dear students, in the previous videos I discussed the third topic of your NCERT syllabus, matrices. And today's class, we are going to discuss the next topic, that is chapter number 4, that is determinants. My dear students, in the previous videos we discussed the matrix. What is the definition of the matrix? What are the types of the matrices? Those all we discussed in the previous videos. So my dear students, we observed if I have the any two matrices, if I add those matrices, or if I multiply the any two matrices, or we can substitute, if I subtract the any two matrices, again I am getting the matrix only. So you can observe, my dear students, if I have the any matrix, if I took means 1 2 3 4, and here if I add with to this matrix, if I add with another matrix 1 2 3 4, or else you can take here it is 1 1. So after adding these two matrices, whatever I am getting the answer, that is in terms of matrix itself. You can observe matrices. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 1 is 4, 4 plus 1 is 5. Like this, again you are getting matrix only. Clear? So now we are finding in this chapter, that is in the determinants, we will find out the actual value of this matrix. We are going to find out. So how to find out what is determinant, that we will discuss. And my students, please observe here it is the number of marks that is in your annual examinations, Karnataka Board PUC examinations, annual examinations. They will ask the number of, here it is weightage for the marks from this topic is, there will be 1 mark 1 question will be there, and 2 mark 1 question, and next 4 mark 1 question, and 5 mark 1 question is there. So total, my dear students, weightage for this topic is 12 marks. 1 or more than 12, 13, 14, or like this, 1 or plus or minus 1 variations will be there. But approximately, if I wanted to tell, means totally this topics contains 12 marks questions in your annual examinations. So please, my dear students, please try to calculate. We will solve the questions from this topic, because this is the weightage of 12 marks. Clear? So now, my dear students, we will discuss what is mean by determinants. Clear? In the class 10th or in the class 8th, 9th, 10th in high school, you may study, my dear students, just I recall the things. So if I have the linear system of equations, my dear students, the linear system of equations means I can take here this. If I have the equation a1x plus b1y equals to c1, and another one linear system of equations I am considering a2x plus b2y is equals to c2. My dear students, please observe here this. If we have the two linear system of equations, now how to find the solution of this we discussed. You may study in your earlier classes in high school. You may study all those things. Clear? So just I am recalling the things. So my dear students, if I have the two linear system of equations, you may see here it is a1 by b1 is, if a1 by b1 not equals to a2 by b2. Clear? So a1x plus b1y is equals to c1. A1 and b1, a1 is the coefficient of x and b1 is the coefficient of y. A2 is the coefficient of x and here b2 is the coefficient of y in these two given linear system of equations. Clear? So in that, my dear students, if a1 by b1 is not equals to a2 by b2 means you can say here it is here unique solution exists. Clear? So unique solution means only one solution you will get. So if you have the two linear system of equations, if you calculate, if a1 by b1 is not equals to a2 by b2 means what it indicates? It indicates that these system of equations have unique solution. So there are so many different cases are there. If a1 by b1 is equals to a2 by b2, then what is the condition? Those all you studied in the previous standards. I mean in 10th, 8th or in 9th you may study such type of linear system of equations, you may study. So just I am discussing here is, just we should know that a1 by b1 not equals to a2 by b2 means we will get for these linear system of equations, we will get the unique solution. So solution means what? solution means, my dear students, solution is nothing but you can get the value of x and y. So those value of x and y, if you substitute here, then the equation LHS will become RHS. Equation satisfies. These all things we studied in the earlier classes. Just I am recalling the things. So my dear students, a1 by b1 not equals to a2 by b2 means these linear system equations will have unique solution, that we know. And another one thing, my dear students, this also either you can write like this or you can write a1 b2 minus a2 b1 not equals to 0. Then also you can say that is unique solution only. So this is whatever I wrote here, a1 by b1, a2 by b2, whatever I wrote here, it is just multiplied here, cross multiplied here. It is a1 b2 minus b1 a2, that a2 b1 or b1 a2 you can write. Clear? So my dear students, if this is not equals to, if these two a1 by b1 not equals to a2 by b2 or a1 into b2 minus a2 by a2 b1, if it is not equals to 0, then we can say here that this linear system of equations have unique solution. This we studied in the earlier classes. Clear? So now the same, I am using the same concept, my dear students. So here come to this my name for the 12th class. Today we will discuss if I have the linear system of equations. If I have, that is a1x plus b1y is equals to c1, and another one linear system of equation I am using here, it is b2y is equals to c2. So these are the two linear system of equations I have, my dear students. So now this linear system of equations I can write in the form of matrix form. How should I write? Please see here it is. Here you can write the given linear system of equations as in the form of matrix form, that is a1 b1 a2 b2 into here x y is equals to c1 c2. Clear? So what I am discussing, my students, if I have the two linear system of equations, these linear system of equations can be written in the form of the matrix form. So how I am writing this? Whether whatever I wrote this in this form, matrix form, is it correct or not? That I will verify now. So if you cross multiply these two, again you will get this only. So you can check, my students, cross multiply. How to cross multiply? Row by column. So therefore here it is first row, first column, that is a1x plus b1y. Row, first column. Next, second row, first column, a2x plus b2y. And this is equals to c1 c2. Again, my dear students, if you simplify this can be written as a1x plus b1y is equals to c1 and a2x plus b2y is equals to c2. Again you are getting the same simultaneous equation itself. Clear? So therefore please remember, any given linear system of equations can be written in the form of the matrix in this form, that is in the matrix form we can write, because if you multiply this, again you are getting the same linear system of equations only. So therefore any given linear system of equations can be written like this form, that is in the matrix form we can write. Clear, my dear students? Now we will today we will discuss what is the definition or what is the concept of the determinants. Clear? So here, my dear students, as I told here it is, so a1 here it is. If you multiply this again, you will getting here it is. Here this a1 b2 minus a2 b1 will determines, or it will tell us the uniqueness of the given linear system of equations. Clear? So this concept I am using here is, I am using the same here, a1 b2 minus a2 b1. This a1 into b2 minus a2 into b1. So what happening, my dear students? This, after solving this, we will get some number. So that number indicating us, what indicates this number indicates? This number indicates the uniqueness of the given linear system of equations solution. So whatever given to you the solutions here, whatever given to you as a linear system of equations, that given linear system of equation, whether it has unique solution or no solution or infinite solution, that determines by using this value a1 b2 minus a2 b1. The same concept I am using here is for the any given matrix, my dear students. For the any given matrix, let us take the matrix A is equals to. So here it is, I am considering this as the matrix. So for any given matrix a1 b1 a2 b2. For any given, this is the square matrix, clear? So for any given square matrix a1 b2, this element into this element a1 b2 minus of a2 b1. So this number, after solving this we will get number. So this number determines the solution, here it is, determines the uniqueness of the given matrix. So therefore this number you can call it as the determinant of the given matrix A. So therefore, my dear students, for any given matrix A, for any given square matrix, please remember the determinant value is possible only for the square matrices. So my dear students, if A is the any square matrix, then the determinant value of this matrix is a1 b2 minus a2 b1, because this itself, this number indicates this number determines the solution, whether it is unique or infinite or no solution, that determines. So therefore we are considering in the same concept here, is we are considering for any given matrix a1 b2 minus a2 b1 is the determinant of the any given value. So my dear students, if I have the matrix, here I am considering one matrix of the order 2 cross 2. For this matrix a1 b2 minus a2 b1, so this is the one number we are getting. So this element into this element we should multiply, minus this element into this element. So after solving this, here I wrote just number, generally we took here it is. So therefore I am writing a1 b2 minus a2 b1. Suppose if you take the numbers, so in that case you will get the one number. So that number indicates the determinant value of the given matrix A. So my dear students, so you can say here it is, for every matrix we are associating to the one number. If you solve this matrix, you will get one number. So for this matrix, every square matrix will associate with the one number. It may be a real, but one real constant number. So it may be real or it may be complex. For every square matrix, we are associating with the one number, or for every square matrix we will get the one number. So that number is called as the determinant of the matrix A. So like this happens for every square matrices. So for every square matrix, if you solve calculate like this element into this element minus this element into this element. So after solving this, we will get one number. So therefore, for every square matrix, we are associating with the one number. So therefore, this will act as the function as well as this will act as the function also. So therefore, my dear students, we can say here it is f. If we can take here it is, we will define a function f from m to capital K. So we are taking the function f from m to k, defined as f of a is equals to k. So f of a is equals to k means what it indicates. So we are taking this determinant concept, we are taking in terms of the function, because function here, what is happening here, it is, my students, for every square matrices. So m is nothing but, so m means what? M means it is set of square matrices. It is set of square matrices. So for every square matrices, we are associating with one number. So that number is calculated by using this a1 b2 minus a2 b1. So this will give you one number. So therefore, for every square matrices, we are associating with the one number. That number may be real or it may be the complex number. So that is depending upon the problem. So therefore, for every set of square matrices, we are getting or we are having, we are associating with the one number, that is k. So and it is defined as f of a is equals to k, where a means here this f of a is belongs to where my dear students, where a belongs to m. So a belongs to m means a is the, m means set of square matrices. So in that square matrices, a is the particular one element. That element is in the form of matrix. So therefore a belongs to m, and this is the small k, my dear students, and k belongs to capital K. This k belongs to capital K. So k is the any number, either it may be a number, a real number or a complex number. So therefore this we defined as f of a is equals to k, and here f of a is nothing but a determinant, my dear students. F of a is determinant of the matrix. So right, f of a is the determinant of the matrix. So like this we will calculate. So therefore determinant means what? Determinant means, my dear students, for any given matrix A, A1 B2 minus this element into this element, A1 B2 minus A2 B1, this is the one number we are getting. So that value is nothing but the determinant of the any given matrix, and determinant is here it is, my dear students, we will write it as like this. That A you can write or you can denote like this. So these are the notations you can use. You can use for any given matrix A, you can write the determinant A like this, or you can write like this, or also, my dear students, for this given matrix A, we can write determinant like this also. Clear? So while reading, you should not read it as the modulus, you should read it as the determinant of A. So either we can write like this, and my dear students, for the matrix we will use the square bracket, but for the determinant we will use like this. We will put the sign like this, determinant of A, and we will write the elements again in the straight like this. In the lines, within the straight lines we should write B2, B2. So this like this we should write. So here it is, square bracket indicates the matrix, and this indicates the determinant. So for any given matrix A, the notation will be like this. That A we will write, or we will write like this delta, or we will write inside the bracket determinant of A, like this we should write. And for the any given matrix, determinant is written like this. Determinant of A is equals to, we should put the like this two lines we should put here, this matrix. So this will indicate the determinant of A. So like this you can find out. So therefore determinant means what? Determinants means, my dear students, for any given matrix A, for any given matrix A, A1 B2 minus A2 B1 is the determinant of the any given matrix A. Like this you can understand. You can understand, and or else you can say it is a function f from m to k defined as f of a is equals to k, where a belongs to the m means what? Set of the square matrices, and small k is the any number that may be, it may be real or it may be complex. So like this, and my distance f of a is nothing but the determinant of the given matrix A. Clear? So this is all the theory behind this. So this is just I use this concept to tell why I am using A1 B2 minus A2 B1 only. I am using this only because already we know this value we are used to calculate to find out the uniqueness, to determine the solution, whether it has the one solution, unique solution, or else it has the no solution or infinite solution. To use that, to know that value, we used this concept A1 B2 minus A2 B1. Clear? The same I am used here also. So therefore, for any given matrix A, A1 B2 minus A2 B1 will give us the determinant of the given matrix A. Clear? And please remember, my dear students, determinant, we can find out the determinant only for the square matrices. We cannot find out the determinant value for the rectangular matrices. Clear? This is the one note we should remember. I hope you understood. And notation is either you can write it like this, or you can use like this delta, or you can use this modulus. And please remember, you should not read it as the modulus, you should read it as the determinant only. Clear? So this is the theory behind this. So as of now, my students, just you should know if any given matrix, if they given to any matrix like this, if they ask you to find the determinant, then you should use this formula. You can take it as the formula itself. Clear? So now I'll solve the questions based on this, then you will come to know. Clear? So take on the next one question we will discuss. So my dear students, the first question I am going to discuss is evaluate. So please pause the video to note it down. So now write down the question, or you can take it as the one example, my dear students. So what is that? Evaluate. So you can take it as the question, or you can take it as the example. Evaluate 2 4 minus 1 2 minus 1 2. My dear students, they directly given to you. Evaluate. This is they given to you, or else take it as a matrix form, so that you can easily understand, or else make it as a find the determinant of A. So A will be that they will give you in the matrix form, they given to 2 4 minus 1 2. Yes, my dear friends, this is the one matrix given to you. So find the determinant of A. So we should find the determinant of this matrix. So now whatever given to you, this is in the form of matrix they given to you. Now I should find the determinant of A. So therefore determinant of A is equals to, so how will you write? Determinant of A is, I told you. So determinant of A is equals to, my dear students, we should find here this by using this A1 B2 minus A2 B1. It means this element into this element minus this element into this element. So therefore this element into this element. So 2 into 2 minus this element into this element. So minus 1 into 4. This element into this element minus this element into this element. This element into this element. So therefore 2 2s are 4. 2 2s are 4. Here it is minus minus plus 4. Minus minus plus 1 into 4 is 4. So therefore 4 plus 4 is equals to 8. So therefore my dear students, for the given matrix A, the determinant value is 8 here it is. Am I correct? Yes. Am I correct? So therefore I am correct. So here it is, determinant of A is equals to 8. Clear? Like this you should find the determinant of the any given matrix. Clear? So any given matrix if they given to you, and if they ask you to find the determinant, you should use this formula. What is that? This element into this element minus this element into this element will gives you the determinant value of the given matrix A. Clear? So that only I told to you, my dear students. For the every square set of, if I take the set of square matrices, then we are associating with the one constant number, one number. This matrix is associated with the number 8. So therefore we can take it as the function f from m to k, defined as f of a is equals to k, where f of a is nothing but the determinant of the given matrix. So here this 8 is the determinant of this given matrix. So generally my dear students, you should remember, or you should think as, for any given matrix, the determinant means what? A1 B2 minus A2 B1. So this will gives us the determinant of the given matrix A. Clear? Like this you can calculate. I will take another one example. My similar type of question I am taking here it is. So my dear students, you can take evaluate. So next, evaluate. The question is evaluate here. Evaluate cos theta. Evaluate cos theta minus sin theta, cos theta minus sin theta, sin theta cos theta, sin theta cos theta. They ask you evaluate, and they given to you, my dear students, they didn't give you like this, find the determinant of A, and they give like this, they didn't give the question. Directly they given to you. Evaluate. This denotes the determinant value. So directly you can understand that the given question is they ask you to find the determinant value. You should understand because directly they given to you the inside the this line indication. So therefore I will find the determinant value. So how to find the determinant? This element into this element. So this implies this element into this element is cos theta into cos theta. This element into this element minus of this element into this element sin theta into minus sin theta. Clear? This element into this element minus of this element into this element. Clear? So this implies that cos theta into cos theta is cos square theta. Next minus plus sin theta into sin theta is sin square theta. And this value is equals to 1 because we know that this result we studied in the previous classes. So cos square theta plus sin square theta is equals to 1. So therefore determinant of this given question is value is answer is 1. Clear? So like this you should solve. Clear? So my students, please remember whenever you have, please remember if the given matrix is of the order 2 cross 2. And please remember my students, whatever rows means what we discussed in the matrices concept or else in the matrices topics we discussed the here it is. This indicates that what is this horizontal line, whatever the elements lies on the horizontal line, so that indicates the rows. Clear? And this vertical indicates, vertical lines indicates, vertical line indicates columns. Clear? This horizontal indicates rows and this vertical indicates columns. The same concept we are using in the determinants also. In the determinant case also, this will indicate the rows and this will indicate the columns, as well as the order of the given matrix is also rows, number of rows into number of columns. Clear? So 1, 2. So what is the order of this matrix? 2 cross 2 because 2 rows are there, 2 columns are there. So therefore the given matrix is of the order 2 cross 2. But my is this is a square matrix. So already I discussed in the types of the matrices. What is that? If the given matrix is square matrix, no need to tell that the matrix is of the order 2 cross 2. You can simply say that the square matrix is of the order 2. You can just if you tell 2, it is understood that 2 rows and 2 columns are there because in the square matrix means what? Square matrix means the number of rows must be equals to number of columns. So therefore whenever you have the square matrix, in such cases if one time you can tell the order that is. If the given matrix is of the order 2 cross 2, then you can say that the matrix is of the order 2. If the matrix is of the order 3 cross 3, then you can say that the given matrix is of the order 3. Like this you can tell. Clear? So now my students, if the given matrix is of the order 2 cross 2, in that case the determinant of the given matrix can be calculated by using this a1 b2 minus a1 b2 minus a2 b1. So after if you calculate this, that will give us the determinant of the any given matrix for the order 2 cross 2. So next my concept is if the given matrix is of the order, here I am taking my difference. First I erase this. So if the given matrix is of the order, please pause the video to note it down. So next concept is you can take it as note or my difference. If the matrix is here this, let us take it. So if A is equals to A, if the matrix given to you is the only of the order 1, this is the matrix of the order 1. In that case, the determinant of A is A itself. Whatever inside the bracket you have the element, that element itself is the determinant value of A. Clear? If the please note, you can remember it as note. So what is the note, my students? If the given matrix is of the order 1. Clear? So this is the matrix of the order 1. If the given matrix is of the order 1, then the determinant of A is the element itself. Whatever we have, the element itself. For example, you can take here, if A is equals to 3, then my dear students, determinant of A is 3 itself. Whatever the element is there inside the bracket, that element itself is the determinant value of the given matrix. It's clear. And next, my dear students, if the matrix is of the order 2 cross 2, A1 B1 A2 B2, if the matrix is of the order 2 cross 2, then the determinant is, then determinant of A is A1 B2 minus A2 B1 will give us the determinant of the given matrix. That already we calculated here. You can take it as example. Already calculated. How this is the matrix of the, this is the given question is of the order 2 cross 2, because 1 2 rows are there, 2 columns are there. So if this is of the order 2 cross 2, so therefore in this case the determinant can be calculated by multiplying this element with this element minus of this element to this element. So this will give you the determinant of the matrix. If they given you only the matrix of the order 1, then you should calculate whatever inside the bracket element is there, that element itself is the determinant value. If the given matrix is of the order 2 cross 2, then you should calculate like this. The number is like this, A1 B2 minus A2 B1. So like this you can calculate. So my students, the more examples we will discuss in the next class, how to calculate the, or how to calculate for any given matrix the determinant value. So please remember, so as your syllabus we will discuss only matrices of the 3 up to 3 order. We will discuss how to find out the determinant of the any given matrix. We will discuss only up to the order 3. Clear? So for your syllabus you have only up to the order 3. So the today's class we discussed if the given matrix is of the order 1, how to calculate the determinant. I discussed the whatever inside the given, whatever element is there inside the given matrix, that element itself is the determinant value. This is the case when the given matrix is of the order 1. Next, second case I discussed, if the given matrix is of the order 2 cross 2, how to calculate the determinant value? The determinant value is A1 B2 minus this A2 B1. That is, this element into this element minus of this element into this element will gives you the determinant value. Clear? So I hope you understood. And if the given matrix is of the order 3 cross 3, how to calculate, that we will discuss in the next video. I hope you understood. Still, if you have any doubts, please comment me. I will reply for that. Thank you.